Hello, students. Welcome back to learn more about yourself. As you recall from yesterday, I gave a really quick introduction to the body tissues and the body systems of human beings. Hopefully, you watch those extra videos as well to give a unique inner perspective of yourself. Well, today we continue with body systems, and we're going to talk about the first three body systems in a little bit more detail today and leave a little bit of time at the end to watch some things that, well, only other videos can show you. So let's begin now with the skeletal system. Skeletal system, some basic facts about the skeletal system that I'd like you to make note of. First, let's make no bones about it, folks. The skeletal system is made out of 206 bones. Now, that is in a mature adult. You're actually born with fewer bones than that because some of your bones haven't fully calcified yet at the point of birth. That makes it a little bit easier for your mommy to deliver you out of the birth canal. And we talked a little bit about that last week with one of the characteristics of mammals. But in a fully grown adult human being, there are 206 bones to the human body. In addition to bones, we also have what are called ligaments. Now, the bones create the essential structure of the skeletal system, but those bones are held together by things called ligaments. The ligaments are long bands of tissue that connect bones across the joints. If we didn't have ligaments, our limbs would basically fall apart. There would be nothing holding together the bones, and we'd be like really flimsy things that would, well, it would be really difficult to function without ligaments. Now, if you're an athlete, it is possible that maybe you have torn a ligament. I remember when I was younger, I used to be a runner. And I remember running cross country in college one year. In fact, it was the last race I was ever in. It was a cross country race that I ran into a puddle of mud. Unbeknownst to me, it was a rather deep puddle. And there was a rock at the bottom of the puddle that I couldn't see because it was just muddy. And I tore the ligament in my ankle. I actually not only felt it tear, but I heard it tear because it went snap. And believe me, that caused a lot of pain. In my younger days, I ran in hundreds of races, and there was only one race I never finished, and it was that one because my ankle blew up to about 10 times its size, and boy, oh boy, that was painful. So I know what it's like to snap or tear a ligament. Imagine taking a rubber band. Take a big old rubber band in your hands and pull it so hard that it snaps in two. Can you imagine how painful that would be on both of your hands as the rubber band snaps? Well, imagine that taking place with an even larger rubber band inside your body, in your ankles. Oh boy, that was painful. Just thinking about it makes me remember the pain a little bit. So let's move on to the next one, which are tendons. Both ligaments and tendons are connective tissue. And connective tissue, as you can imagine, connects different things together. Ligaments connect bone to bone. Tendons connect bone to muscle. And, there are lots of tendons in the body as well as lots of ligaments in the body. If it weren't for tendons that connect the bone to the muscle, well, our muscular system wouldn't do much of anything because it would just contract and expand. But if it's not attached to anything, we could have bulging muscles, but it wouldn't move our arms, it wouldn't move our legs or anything else. So we can be very thankful for the tendons that connect our bone to our muscle. Brings us to the next one, which is called cartilage. Cartilage is kind of like, do any of you spend any time cooking in the kitchen? If you ever do any cooking in the kitchen, maybe you have used a non-stick pan. Non-stick pan, you scramble eggs and you accidentally burn them and the burned eggs don't stick. It just slides right off the non-stick pan, right? Or at least that's what the commercials will lead you to believe. Well, cartilage is kind of like a non-stick pad or pan, but it's really like a pad because the cartilage is a tissue that is rubbery, that provides lubrication between joints. It's like a non-stick surface. Cartilage can be found where bone meets bone, and it is intended to prevent bone from rubbing up against bone because that would be bad. Sometimes later in life, when you get a lot older, your cartilage may break down and you may have bone rubbing on bone, and boy, you'll be in a lot of pain if that happens. Now, I would imagine that most of you have probably seen cartilage in real life. No, not in your own joints. Don't rip apart your own fingers or feet or knees or elbows just to look at the cartilage in your own body. No. I'm talking about another animal. How many of you have ever eaten a chicken leg or a chicken wing or a thigh from a chicken? How many of you have ever eaten chicken with bones in it? If you have you ever gotten a piece of gristle in your mouth, that kind of chewy stuff that, well, you can't really chew? Or have you ever seen that yellowish material between the joints of chicken legs and thighs? If you have, that is cartilage. And that's kind of what your cartilage looks like as well. And not that I would ever want you eating a human leg, and I won't even speculate that if you did, but that cartilage probably has a very similar texture to it that chicken cartilage does. It is a lubricating connection on the bone that prevents bone from rubbing up against bone. That is its function, and a very important function as well. Now, the next part of the skeletal system, you may not even necessarily associate with the skeletal system. In fact, some of you may not have known this. Your bone contains what is called marrow. If you have a pet dog, maybe you've given your dog a bone with marrow in it, and the dog is like loving the bone because they're trying to get to that yummy stuff on the inside of the bone, which is called marrow. Well, bone marrow, believe it or not, is where your red blood cells are born. Yeah, your blood that is coursing through your body, and we're going to finish up tomorrow with talking about the circulatory system, so we'll talk more about blood tomorrow. But that blood, those red blood cells, are actually produced inside your skeletal system, inside your bones, in what is called your marrow. So there are blood vessels that go in and out of your bones because that's where your blood comes from. Did you know that? I think that's pretty cool, that the blood in your body actually comes from your bones. So your blood and bones are very much connected in your body. Without a skeletal system, without that marrow, you would not have blood. Now, there are some bones that are larger in your body than others, and it's within those larger bones, like your femur and your pelvis, where you can find the most bone marrow, which is where your blood is produced. So, skeletal system, 206 bones, Ligaments connect bone to bone. Tendons connect bone to muscle. Cartilage, where bone meets bone, and marrow that produces your red blood cells. Study that information from the skeletal system. I can pretty much guarantee I'm going to quiz you on it on Friday. So make sure you know the difference, especially between ligaments, tendons, and cartilage. But let's continue with the next body system, which is the muscular system. Now, don't gaze too closely at this picture. I know some of you might be looking at that tightly squeezed gluteus maximus in this picture. Gluteus maximus, by the way, is the name for your butt. All right, the gluteus maximus. So don't be looking at the butt. Let's talk a little bit about the muscular system in general. An average human being, when you are fully developed, have over 600 muscles in the body. It's almost 3 times as many as you have bones. You have more muscles than you have bones. And these bones are not all the same. In fact, there are, 3 different categories, groups, or types of bones, each of which serve their own unique function. First, probably the most common of which that you are familiar with, these are the skeletal muscles. The skeletal muscles are the ones that help you move your joints. The way I'm moving my neck right now, I can move my fingers, I can move my arm, I can walk around, I can talk right now because of skeletal muscles. Skeletal muscles are moving the joints of your body so that you can function. And most people, when they think of muscles, that's what they think of. You think of maybe a bodybuilder and someone who is exercising muscles like the biceps and the triceps to make your arms look bigger. But those aren't the only kind of muscles, and you might argue they're not even the most important kind of muscle. Let me show you why. The second type of muscle are called cardiac muscle. And cardiac muscle are the cardiac muscles are what make your heart work. It's what your heart is. It's what your heart is made out of. Cardiac muscle. It's a totally different kind of muscle than skeletal muscle. It's structured differently, it functions differently, and you could live for a period of time without skeletal muscles. You can't live for more than a few minutes without cardiac muscles, because if your heart stops beating, guess what? You die. So you need your cardiac muscles, which are your heart, that keep you pumping that blood throughout your body. And again, later in the week, we'll talk more about the cardiac system, the cardiovascular system, where the heart is it is the primary organ of the cardiovascular system. So again, we'll finish up our notes tomorrow talking more about the heart. The third type of muscle are called smooth muscles. And most people may not even give smooth muscles a second thought. But again, without smooth muscles, you wouldn't be able to breathe, much less talk, or anything else for that matter. I know we don't think about it often, but smooth muscles are involuntary muscles. What does that mean? Involuntary muscles the word involuntary means you don't have to think about it. So that's probably why we don't think about involuntary muscles. Ba-dum-bum. Did you get it? So involuntary muscles, the smooth muscles of our body, some examples of them include the diaphragm, which is under our chest cavity, which enables us to breathe 24 hours, 7 days a week. Without your diaphragm, that involuntary muscle causing you to breathe, you'd stop breathing. And after a few minutes, you'd be dead. The other type of smooth muscle, and there are others in the body as well, but the second major type of smooth muscle exists in your digestive system. Your digestive system is lined with smooth muscles. Why? Well, because when you chew your food and you swallow, as soon as it goes down beyond your mouth and into your esophagus and the rest of your digestive system is moving that food along by gently squeezing. It's called peristalsis, but it's done through the use of smooth muscles. We'll talk more about digestion in a little while. So these are the three types of muscles that exist in the body, and the ones that probably come to mind first, the skeletal muscles, are really the least important. I mean, they're all important, don't get me wrong, but without cardiac muscles and smooth muscles, you wouldn't even have a chance to move your skeletal muscles. But this description or discussion about smooth muscles, especially in terms of the digestive system, is a great segue into the digestive system. So let's talk about it now. Ow, I just hit my knee. The digestive system. And by the way, when we're finished with this video, I am going to link you to a really cool video taking you on a tour all the way through the digestive system, if you know what I mean. So, what is the digestive system's function? Well, its function is to break down food. And it starts by eating food and chewing food. But food is broken down by the digestive system for cellular use. Cellular refers to not your phone, but the basic building block of all living things, including you. Your cells are the primary goal of your digestive system, breaking down all of the big yummy food that you eat in order to provide the nutrients that your very cells need. And so there are 5 major parts to the digestive system we're going to briefly explore here in our notes. The first is your mouth. And in your mouth is where digestion begins. I know because I've been through the cafeteria on more than one occasion. I know that some of you just take food and shove it in your mouths and you don't even bother chewing before you swallow. That is not good on so many levels, not just social etiquette, but physiological levels. Digestion is supposed to begin in the mouth through what is called both mechanical and chemical digestion. Mechanical digestion is what occurs when you chew your food. Your teeth go up and down, and every time you chew your food, you're breaking it down into smaller and smaller pieces. That is mechanical digestion. And that mechanical digestion is aided by the saliva in your mouth. In fact, if you were just to think about a yummy kind of food right now, some of you might have your mouths begin to water. That's because the saliva is being produced by salivary glands. These salivary glands produce saliva, which is not just water. It also contains a couple of enzymes. I think they're called ptyalin and pectin. And these enzymes are chemicals that start to chemically alter and change the makeup and the content of the food that you are chewing. It is so important to chew your food thoroughly before you swallow, because it will make it so much easier and healthier for your digestive system to undergo the process of the major goal, breaking down the food for cellular use. So again, the mouth is the first major part of the digestive system, and it's through your mouth that mechanical and chemical digestion begin. So your homework today, the next meal you eat, chew your food. In fact, I would challenge you, for each mouthful you consume, chew your food 20 times before you swallow it. Do it intentionally, consciously. Think about it before you swallow and report back to me tomorrow as to how you compare chewing versus non chewing. And tell me which is easier to swallow, unchewed food or chewed food. Now, with Jello, it probably doesn't make that much difference, but let's say you bite into a big juicy apple. Ooh, I don't know if you've ever swallowed, perhaps accidentally, a big chunk of apple without swallowing it. Ouch, compared to an apple that you have chewed thoroughly. It's much easier to swallow applesauce than apple slices. All right, let's move on to the next component of the digestive system. So here, you have written down, hopefully in your notes, number one is mouth, where chemical and mechanical digestion begin. The second major part of the digestive system is your esophagus. Your esophagus is the tube that connects your mouth to your stomach. And as I mentioned before, with those smooth muscles of your muscular muscle system, we've got muscles surrounding your esophagus, squeezing rhythmically the food as you swallow it. This is called peristalsis. Peristalsis is the rhythmic movement of smooth muscles through your digestive system. To give you an illustration of this, imagine brushing your teeth. How do you get the toothpaste out of the tube and onto your toothbrush? You squeeze the tube of toothpaste, right? By squeezing the tube of toothpaste, you squeeze the toothpaste out of the tube. That's basically how things move through your digestive system. It's being squeezed. Thankfully, you don't have to think about squeezing your smooth muscles because they are involuntary. You don't have to think about it. It just happens by itself, thankfully. All right, number three is your stomach. Your stomach is a bag-like organ that produces gastric juices. Now, these gastric juices inside your stomach are otherwise known as hydrochloric acid. Yeah, maybe you've heard of that before. It's a pretty strong, nasty acid. Hydrochloric acid is extremely corrosive. You wouldn't want to be drinking hydrochloric acid. It will burn the inside of your mouth. It'll burn your throat, and you'll be going to the doctor, if not the hospital. But some of you might be thinking, well, wait a minute. If our stomach is producing hydrochloric acid, isn't that just as bad? Thankfully, we have a special lining on the inside of our stomachs that protect the stomach from the hydrochloric acid. But if you've ever had heartburn or acid reflux, or you've ever vomited, thrown up, you probably have tasted some of that hydrochloric acid, and it does burn the back of your throat, your mouth, and everything on the way up. And it's because that hydrochloric acid, that gastric juice, is someplace where it doesn't belong normally. So thankfully, we have protective lining in our stomachs, which protect our stomachs from the gastric juices. But those gastric juices, that hydrochloric acid, further changes the food that you've swallowed chemically. It is chemically breaking down the food even further so that your body can absorb it and ultimately provide the very cells of your body the nutrients they need to survive. But we're not done yet. Let's go on to number 4. Oops. And number 5. All right. So number 4 and number 5 are your intestines. Number 4 specifically are your small intestines. Now, your small intestines are the vast majority of the length of your intestines. All the inside of this image here are your small intestines. I forget how many feet we have. I think we've got like 9 meters of small intestines. You know, lots of feet of small intestines within our bodies. And it is through the passage of food through the small intestines where most of the nutrient absorption takes place into our circulatory system. Our cells are literally fed through the absorption of nutrients from your small intestines. But it doesn't end there, because we also have our large intestines. And our large intestines do a few things. Number 1, it is where vitamins are produced in our large intestines. And vitamins from the food we eat are manufactured in our large intestines and absorbed into our body and utilized for various things depending upon the vitamin. It's also a storage location for the solid waste material. And our solid waste material, when it is completely digested, all of the waste material then is removed from the body through the end of the large intestine, through the colon, and finally the rectum and anus. And if you want a close-up view of this process, I encourage you to watch the video next on the digestive system. So I'm going to end our notes here for today while you check out an inner tour of our digestive system from start to finish. So on that happy thought, I'll just say bye-bye.